Hi everyone, so good afternoon. My name is Viv Richards. Sorry, skipped a few slides. So my name is Viv Richards and this session is titled Spot the Difference, Automating Visual Regression Testing. So we're going to be looking briefly at why just manually testing is a bad thing, why too much end-to-end automation is a bad thing, some issues with visual testing, but ways that that can help to help with your sort of end-to-end testing. I've only got 30 minutes. We've got 68 slides, but as a Welshman, I speak quite quick anyway, so hopefully I'll get through them all. If you do have questions, if you can keep them till the end, if I run out of time, you can sort of grab me downstairs, what have you, and we'll have a chat, if that's okay. So quickly, just about me. I was previously a software engineer, specialised in .NET, C# MVC for about 7 years. I'm currently a senior test engineer at Vizolution, based in not-so-sunny Swansea. I'm a CodeClub volunteer, so I help to teach children to code using Python, Scratch, HTML, CSS. If you get the opportunity, it's a fantastic thing to do. Work will give you time off to go off and teach children. Really rewarding if you have your own children, so you should find out about that. It's brilliant. And I'm an organiser of 2 other conferences as well. And sorry, I've missed my own punchline. So yeah. If you are a cricket fan, apologies. I'm not who you were expecting. I'm not the West Indies cricketer from Swansea, but apologies about that. So, why automate end-to-end tests? It's a lot more reliable, or can be, as it's performed by tools or scripts, and it's a lot faster as well. Being humans, we make mistakes. Things generally take a lot longer. But there's a lot of common automation issues. So a lot of investment is required to get your staff up to speed, to use new frameworks, tools, to get on board with this new framework or tool that you're using. And it's practical as well when you're going to sort of rerun over the same test cases. If they're throwaway tests, then it's probably pointless. So you invest in a lot of time in something that's just going to be thrown away. But the important thing for this talk specifically is that automation testing does not entail human observation. So whilst they can tell you that things are rendered somewhere within the DOM, they can't tell you that they look how they should. So you can sometimes get passes, but for the wrong reasons. And it can be a slippery slope as well, because you get a lot of people who get a new tool, or they hear about Selenium or automation, and they just want to automate everything just because they can. So just the simplest of tasks, which could be throwaway, will all of a sudden become sort of automated because testers can, or devs in tests can. And this is something, so just before we get into lots of discussions and debates, I appreciate not everyone will agree with the testing pyramid, but this is, from my experience, what I tend to see. So I see a lot of this, especially moving from dev to test, whereby developers are so busy implementing features that they sometimes skip over UI integration tests. And then to make up for it, the testing teams, what they do is they'll, because they can, write lots of end-to-end tests, and then you get something like this, whereby you get tests that take too long to execute, and they're very expensive as well to, firstly implement and maintain as well. And then you sort of have discussions then with the teams and say, well, I don't agree with this approach. Perhaps we should start to look at, some TDD and some best practices to try and get some tests lower down in the stack, get quicker feedback, cheaper to implement, cheaper to maintain. So you get something like this, which is a start. But the problem is, even if you get 100% unit test coverage, it doesn't mean that your system's going to play nicely together. So you're going to get something like this. And you get a lot of this as well, so for agile testing. So if you work as part of an agile team, you want that continuous feedback, you want to fail fast. If you've got these tests running on something like Jenkins or TeamCity, ideally you'd get your code checked into Git or whatever you use. Code would build, unit tests would pass, and at each point, so you'd have your unit tests, integration tests, UI tests, and visual tests. At any point that these tests fail, you should have these quick feedback loops. But when you don't have the unit and integration test and you're relying solely on end-to-end UI tests, the feedback loop is so slow that you're not going to be able to adapt to change quick enough. So it's a real issue, and I see this a lot. So this is the testing pyramid. Obviously, I expect a lot of you have seen it before. So this is something that when I identify teams using a lot of reverted pyramid sort of tactics to approach testing, this is something we try to go toward. So a lot less UI tests whereby so the product that I work on is sort of duplicated a lot for different customers, but you can't reuse the tests. So what we try to do then is just to do functional happy paths through the software with Selenium, and then we try to get into service and unit tests then lower down the stack, and we start to pair as well with the developers. So perhaps there's a reason that they don't have the unit to integration tests, perhaps they don't know what to test, but they have the skills to code it. So we try to pair up a lot as well, just to try and sort of identify edge cases, to try and build further quality further down the stack. So why not just stick with manual testing then? UI testing does take a long time, and manual testing allows us for human observation. The problem is that it's time intensive. It's not always accurate, as I've touched on, and we're human, we make mistakes. And it's time consuming. While you're manually checking through something, you're stuck on that task. You can't go off and do something else. If you can check that end-to-end tests work, if you can run end-to-end tests, then you can go off and do some exploratory testing, run through some test scripts. So it frees up a bit of time. So just manual testing isn't enough. And it's only practical when test cases are run over and over again. So I come up against this quite a lot as well. So even with the best will in the world, you have developers on board to try and help build nice tools and frameworks, and the testers build them. Even when you provide the wheels, people don't have time to stop and put them on because they're too busy. And then you get into something like this, whereby even though you could automate some end-to-end happy paths to free up some time so then they can go off and do exploratory or manual testing, they can't because they don't have time, because they don't automate, and they're just stuck in this constant loop, which they need to break basically. So there's many options out there. I guess many of you have sort of used these or seen these. And it all depends really on, when you start to look at sort of automation testing for UI, it depends on lots of things like the operating system you're using, the language which your application's coded in, the type of application you're testing, so Slendroid for Android, that type of thing. Depending on the sort of learning curve as well. So if you have typically a team of manual testers who don't really want to write code, perhaps you'd go for something like Visual Studio Coded UI, where it's like a recorder tool where you can just start to record your tests. We chose Selenium. Well, I say we chose, it was chosen before I joined the company 11 months ago. The reasons initially being that it's open source, so anybody can sort of have a look at what things are doing, then get involved in the community because there's a massive community of support. Can operate on almost any operating system. And for us, it supported .NET, which is what we use for development. And it supports a range of browsers as well. And for us, we have to support Chrome, i.e. Safari, and quite recently then Android, the latest, and iOS. But it's not a silver bullet, and people should be aware there's a lot of things that can cause you a lot of pain going further down the line. And sometimes it's not quite obvious to see until you're too far along and you've invested a lot of time and money in your framework, and you're too committed then to sort of continuing. So there's things like browser compatibility issues. So like I touched on, we test for Firefox, Chrome and IE. So different browser drivers execute at different speeds, which can catch you out, and all of a sudden you start to have to add like weights and things like that to try and slow tests down, to try and keep it all consistent. And they render slightly different as well, which is a massive problem when you're trying to do visual comparison checks. Execution speed. So for the types of applications that we automate end-to-end, we have like a customer and an agent, and they both have to log in, and then the agent has to create a session and the client has to go in, type in the session code, and it can take a while. So a typical end-to-end journey will take maybe 15 minutes for the tests to execute and give you some feedback. It's a long time. Maintainability. So again, like I've touched on, because of the different browser renderings and the execution speeds, all of a sudden your code base can sort of start to grow and grow because you have having to write in if this driver type, then this driver type do this, wait for this element, retry do, and all of a sudden your code starts growing and growing into an absolute mess. So I wanted to ask, how valuable are these tests? So this is an example of a form that I've seen whereby a test engineer has gone along, written some Selenium, so this is Selenium C# using a WebDriver. They've written some tests, and all they're simply doing certain that the text is rendered on the page. So they run the tests, and we had a call basically in support. All the tests were run, they passed, but the customer called up and they couldn't actually use the contact form. This is what they were basically, something like this, they were seeing on the screen. And when the tests were running, they could see in the DOM that the elements were there somewhere. But the problem was, there had been a CSS break and change. The element was actually rendered in the DOM, so the test passed because they could find the element in looking in it. But the element wasn't visible for the user, so they couldn't actually interact with the form without going into the DOM and inspecting and fiddling around with the code. So these tests, they had very little value in that respect. So some of the things that we do, I thought I'd share because they're quite nice. So to try and make your tests a bit more maintainable, you can use like common object page helpers to try and keep it simple and keep your code dry so you're not repeating yourself. But one of the really good things that we tend to do, I'm not sure the name for this. I don't know if we've made it up or whether someone's stolen it and we've just adopted it, but we call them QA selectors. I'm not sure if anybody knows what they're actually called. So what we do is, so what these will do is help the team make less breaking changes to the UI. So for example, on the right-hand side, we have a form. The above code is what the code would look like before adding the QA selectors. So what we do is we identify the elements and we say, well, it's QA hyphen, element type hyphen, and then the name of the element. So this gives us a few benefits. So some of the applications we deal with have generated IDs, and IDs should always be unique. But in this case for us, they are unique, but you never know what they are. A lot of the time you'll get classes which are reused because developers aren't really thinking about automation, so they will repeat class names, so then all of a sudden you have to, within your tests, start going within various elements and drilling down. So this will allow you to always know that your element is there. It makes your test cleaner because you're always using driver find by CSS selector. And when a developer comes to start playing around with the front end, they can see that that element has automation attached to it because you're using the QA selector, so it's less likely going to be breaking changes then to the code, to your tests. So it's really good. So we just had lunch, so I'm going to try and keep you all awake. I want to know how good you all are at spot the difference. So I'm going to show you two screens, and I want you to see in about 20, 30 seconds how many differences you can find. All right? Okay, time's up. Sorry, we've run out of time. Sorry, I just looked at the thing. So did anyone find one difference? More than one? 2? 3? 4? 5, okay. Excellent. So there were 6, but that's brilliant. So unfortunately, the screen's cut off 1, so you probably wouldn't have found it anyway, to be fair. There was a hyphen with a sign up. So it's quite interesting that typical sort of Selenium UI end-to-end tests, they pick up things like the text. They pick up the text here and here. We've got padding here, so this would never be picked up by any type of sort of end-to-end test. And here we've got sorry, there's a little sort of lip on the end of the P. So some of these things would never get picked up because they're images or because it's a style change. And the problem is as well, that was a short amount of time, and how do you know when to stop? How do you know when you found them all? It's tricky. So what we're going to look at now then is the visual stuff. So it's looking at how we can add more value to the UI level and start to bring in some of this typical sort of manual checks that we would do in our regression testing. So what if we could simply then say, this is my base image, this is what I've agreed with the product owner and signed it off after the application's been built. Now every time I run my tests, it should equal the latest image basically. So before we jumped into creating a visual framework, very quickly, there's lots of options out there, really good ones. Again, it depends on if you want to keep the language similar to your current test framework or to what the developers are using. So some are JavaScript based. Applitools is really good. It's you don't write code. It's like a UI where you can just drag areas. So anybody could basically use that, and you can identify things like just layout changes, everything, just text. So it's really good, but it's very expensive. Wrath, I think, is a BBC tool. It's on GitHub. It's a really good one as well, and Phantom CSS. The issue with other offerings for us was that they didn't work straight out of the box. They had a lot of bloat, and we already had a framework that had grown into a monster, and we didn't really want to start just throw in, frameworks at it. It was a steep learning curve, and we needed the framework to work with our existing helpers. It had to be .NET C#, and it had to work with our current Cucumber sort of solution. They had small communities, so there would have been a lack of support for us, so we thought it'd be better to build it in-house, so we knew exactly what it was doing. And the costs as well, not only to sort of buy something, but to actually get people on board and start using it and supporting it and extending it. So it's still in development. There's lots of challenges that we've had. Hopefully the things I'll discuss now you can apply to anything around visual testing. So one of the first things that we had issues with was reliability. So like I touched on very early on, browsers render things slightly differently. So this is a screenshot that was taken in Chrome, and then the test ran in Firefox, and all the pink areas are where the framework thought that it was different, but it's just a case that the driver actually renders it slightly differently and pushes things over. And so it was a false positive, failure. Execution speed. So this was one of the things that we wanted to test. So this was basically loading up Google, Chrome, going to the Google homepage, checking that the snapshot resembled what we had as a base image, which took 4 seconds. A similar type of test that we run where I work would take probably, 10, 15 seconds. And this gives us more value as well, because not only are we checking that elements are rendered within the DOM, we're actually checking colors, font sizes, layouts, everything. We'll have another little game. So we wanted to see how quick that the visual framework could be. So what I want you to do is, there's going to be 2 images. Where's Wally? He's on the right, and he's not on the left. But basically, I want to see how quickly you can find him. All right. And these are the exact images that the framework used as well. I'll zoom in a little bit to give us a help. Zoom in a little more. Anybody? Yeah? Yeah. So there he was. So it takes a lot of time. When there's a lot of information on the screen, it can take an awful lot of time just to try and check if everything is as it should be. So the machine, 293 milliseconds, and that was the code. Basically, give it 2 images, get the difference, it's exact the same. And that's it. And what you see here is the original image and it's drawn pink over where it found the differences. So you get that visual feedback. So not only do you know that the test failed, you can actually load the difference image and see exactly what was different. So it's really powerful. Maintainability. So this was the old code again for the contact form, which was 6 lines of code. So using the framework, it's only 4 lines of code. You could make it less. And it gives more value as well. You're checking a lot more things here. And we deal with various journeys for customers in different countries. So sometimes a special character or something, you may just skip over it. This will pick up, it's pixel perfect and will pick up anything that you throw at it, basically. You can take it further. So if you use SpecFlow at all, what you can do is then, so you can pass in parameters. So the code at the bottom stays the same. So it's 4 lines of code. And basically just pass in the home page and the page name. And what you can do is you can get the framework to actually generate the base images for you as well. So you don't have to create homepage.png and contact.png. First time you run the test, it will say the base image doesn't exist, and it'll output it in the window. It'll say, do you want to save this base image as your new image? And then you'll just run the test. So all you have to do is provide the home page, the name you want, basically, and this code will always remain the same, and you can pass all your pages through for the site. So it's really powerful, easy to maintain, and it gives you a lot more back. Again, so you can easily identify where the differences are. You get this visual image which gets output. If you run Jenkins, Team City, something like that, when you get your test summary, you get your artifacts. So all these images are attached to your test runs. You can quickly download them, or you can set up notifications. And you get these images sent to you then, so you can quickly identify, if there's a CSS regression or something like that, and you can quickly resolve the issues then. Accuracy, so it's pixel perfect. There is a tolerance, so if you need to allow for certain changes, you can set that. Image quality difference, so there isn't any difference. It's the same drivers that take the images. You can set the driver height and width, so if you've got a responsive website, you can take base images for each device type, and then you can compare against that device type in your test specifically. So it won't use this image for all of these. You'll have 4 base images, so you can then start to test out responsive sites and that type of thing. So challenges so far for us, there's been quite a few. Maintaining base images. We thought that we could just have 1 base image, but for each page, but you have to, because of the differences within driver types, you have to have a base image per browser type or driver type. So you'd have to have 5 for the Google homepage, basically. But what you can do in the framework is you can detect which driver type you're using, and you can start to manage that yourselves, and you can get it to take the base images for Chrome. So you'd have Google homepage.chrome.png, and you'd have that for each of the driver types. So this becomes, nothing to concern yourselves with then. Screenshots. So by default, when you're taking snapshots with Selenium, it's a W3C standard that you can only take a snapshot of the what's in the viewport. But what you can do is, we've enhanced the framework, and I think the others do the same thing, that you can take full page screenshots. You can also as well drill down to elements by ID and CSS selector. So what this allows you to do is, if you have something like a pattern library or something like that, or branding for your customers, what you can do is you can get down to, if you had a button with a class of button, you can just take snapshots of all your button types, of all your input field types, various things, just your headers for the customer, and you can start then just running tests on element level. You don't have to do the full big bang. So it's really, really good. Screen resolutions. So when I first got this working, we had a review, and I ran off to show it, and ran into an issue whereby I'd created the test locally. We'd gone into a review room, run the test, and I had to remote into the machine. And so the screen, basically what had happened, the drivers opened the window and they were maximized. And so when it took the snapshot, it was actually a different size. So a way to get around that is, for your base images to always work, don't set maximum on the driver. you just set height and width. So regardless of the screen size, the browser window is always going to be the same size. So the base images will always match. They'll be the same height, same width. Hardware issues. So this was something that came up quite late on. So there's a slight difference to do with anti-aliasing in how computers render web pages and things, depending on the driver type, various hardware. And so we were getting issues whereby red heading would slightly be a little bit more faded on someone else's machine, which was really difficult to see by eye. But this was failing. So what we had to then introduce was a tolerance to allow for a slight difference. Since then, something that we've started to look at is to create a service whereby the service takes the image. So we've got one single point that will always take the same image off the same hardware and then return that back. Another thing you can do is, as well as get the difference image back with the pink squares, you can actually get a difference image back with the numbers. So it tells you where or how much each area differentiates. And we've put that into a config. So you can run a test firstly. It'll fail because there's a difference of, 10 tolerance. And you can just put that in the config and it'll use that as the default tolerance. So it can be fiddly. So it's something that we're looking into at the moment. Storage. So when you start to then look at if you support more than one driver type, so if you support Chrome, Firefox, IE, all of a sudden then you have to start thinking about storage because you've got lots of applications, lots of different web pages that you take snapshots of, depending on the size of your driver that you're launching, things can start to grow and grow. So we're looking at trying to put stuff onto AWS at the moment. Dynamic content is quite an interesting one. So we deal with web pages whereby the customer will interact on the web page and then a date will get stamped on the form. So to try and mimic that, it's quite difficult because obviously every day we run the tests, it's going to fail because the date is wrong. So to get around that, what we can do is we actually blanket the element. So what I mean by that is, rather than fiddle with the DOM, we'd find this element by class name, find out its X and Y coordinates, and then just blanket a div with Z index over the top of it. So it'll just float over the top. And what that allows us to do then is, it's not fiddling with the DOM at all, really. The structure of it, it's blanked in a div over the top, and then we'll take the snapshot. So every time that test is run, if you imagine this was a date area, it'll compare everything except this because it'll just be a purple block. So it allows you to then try to get around some dynamic areas. Moving elements, CSS animations, videos. These can be quite tricky, but what you can do is, on page start, you can inject some JavaScript. You can start to then stop transitions for CSS3, HTML5 videos, you can just disable. So you can do some sort of jiggery-pokery with injecting some JavaScript via the driver. And that's how we've got around that. Visually checking documents. So we deal with banks and mobile providers. And so after a transaction, they'll want the customer to be able to download a PDF copy of the contract. And so we've had to be able to, basically, we've used a third party to allow us to extract all pages from a PDF as images, and then that will just run into a framework. So all of a sudden we can check a 12-page document in a totally different language and assert that it is exactly how we expect. And if it differs, we can pinpoint exactly why it differs. And it's really handy when you get a new version of a document and the customer says, I've just changed this heading. You can run it through the tool and you can actually see exactly what differs. And it's very quick. If you think, it could take a day of someone's time to run through a PDF to check, is it how it should be? Whereas you can run it through this and you know in seconds exactly what's wrong with it. Upcoming challenges. So PDF dynamic content. We use a third party called Aspos. And what you can do with that is you can either find elements by it renders, the way you can find elements is by if you had a screen with boxes, you can try and find a box of a certain size or with a width around it, or you can use regex. So what we've done is we've found We've written a bit of code that will work out what today's date is, find the date that we know is going to be stamped in the document, and then we find it by regex, replace it, and then we know that every time we run comparison on the PDF, it's always going to be, it's always going to be the same. I don't know what's happened. It's always going to be the same size. I don't know what's happened. I'm pretty much at the end of it anyway. If you have any questions, I can share the link. I'm not sure what's happened with this, I'm afraid. I do have a link to a GitHub repository where the code is free. You can have a look at it. It's very rough and ready. But yeah, thank you very much. That's it. Cheers.